Okay, so we're on day 3 of trig functions of any angle, okay? This was our unit circle. We learned how to fill it in, and then this we, of course, changed because that one's wrong. This should have been cotangent. So once you have your unit circle, you should be able to easily find your sine, your cosine, your tangent. Your sine's your y, your cosine's your x, your tangent is your y over your x. As long as you know your over 3s, over 4s, over 6s, and then the quadrant angles, you should be able to figure out any of those. And then obviously the reciprocal functions, we would just flip. So 1/2 of your quiz is going to be a blank unit circle in which you'll fill it in. And then the other half is going to be here, either find the sine at an angle or find the angle given the sine. So that's what we're going to finish today. That's what we didn't get to finish on Friday. So we talked about this. There's 2 ways to use this, okay? One is if you're actually finding the reference angle. So if you want to find the reference angle and you're in radians, right? So I'm going to draw this off to the side because it's a little bit different. If you're in radians, if you're in the first quadrant, the reference angle is the actual angle that you have. So if you had like pi over 5, then pi over 5 is going to be your reference angle. If it's in the first quadrant, then it is the same. If it's in the second quadrant, you either do pi minus theta or you do 3.14 minus theta, and that will give you the reference angle. So if it's got pi in the answer, you're going to keep the pi like just pi minus whatever it is. And if it doesn't, if it's a decimal, then you're going to do 3.14 minus it. In the third quadrant, you're going to do 3.14. Wait, sorry. You're going to do theta minus pi or theta minus 3.14. So now we're saying it's in between pi and pi over 2, 3 pi over 2, or 1.5 pi, or it's in between your 3.14. And then on the right-hand side, if it's in that fourth quadrant, then it's 2 pi, which would be 6.28 minus theta or 2 pi minus theta. So that's if you want to find the reference angle. On the right-hand side, it's kind of mixed, so it's like confusing, I think. So if we are given, which is the next kind of examples, if you're actually given the trig function and you're looking for theta, this is when we work backwards. So in the next examples, like if it said that the sine of something, sine of theta was, I don't know, 0.75, we would do inverse sine of that 0.75, and this we're keeping in radians. And then that's going to be the first answer, which would be in that first quadrant. Again, whatever you get is your answer. In the second quadrant, whatever you get, you're going to subtract from 3.14. In the third quadrant, you're going to add it to 3.14. And in the fourth quadrant, you're going to do the 6.28 minus the theta. So if it was the sine of theta is a negative 0.75, that's going to happen in your third and fourth quadrants. So that's where we left off. I think we did one example on that next sheet, right? And then those were all involving your calculator, and then you're going to do it without. So this one, we did 16, right? We said it said use a calculator to find theta on the interval of 0 to 2 pi. Round your answers to the nearest hundredth. And again, we're keeping, these are in radians. So the mode on your calculator should be in radians. Mine still is, yeah. So if I look at 17 here, it says the cosine of s is 0.7826. So I'm going to do cosine -1 of 0.7826. And I'm, again, making sure my calculator's in radians, 0.7826. And I get theta, or s, which is the variable they're using, 0.67196. It said nearest hundredth, right? So that's around that. Now that's in the first quadrant. So because cosine is positive, we're looking for the angle in the first quadrant, and we're looking for the angle in the fourth quadrant. So I'm going to do 6.28 minus the 0.672 to get the other angle. And I get 5.608. So those are the 2 angles in radians that would give you a cosine of 0.7826. Yeah. because it's cosine positive. So you use your all students take calculus, and that will tell you which quadrants to pick.
And you couldn't pick the first quadrant?
Well, the first quadrant, you have that answer. That's what this one is. So you already have that one. Yeah. So for 18, now it's cotangent. Remember with these are the ones that we do in the weird order. This would be tan -1 of 1 over 0.2994. So I second tangent, 1 divided by 0.2994, and I get the first angle, 1.2798, so that's going to bump and bump. And it's tangent, so where else is tangent positive? First quadrant and third quadrant. So I'm going to do 3.14 plus 1.280. And I get 4.42. Yep.
How did you know not to subtract pi?
So if it's in the third quadrant and we're using the angle to get the answer, that's when you're going to add it. Because it's got to be bigger. It's got to be bigger than 3.14. All right, then 19. So again, reciprocal function. This would be sine -1 of 1 over 1 point. Oh, this shouldn't have 2 points. It's 0.0219. So second sine 1 divided by 1.0219. And I get that the angle is 1.3633. So that's the first one. We're talking about sine this time, so sine is going to be positive in the first quadrant, which is the one you already have, and in the second quadrant, so I'm going to do 3.14 minus 1.363. 1.777. Okay, and the last one is negative. So I don't know if you remember these, but before that last test, we talked about if they're negative, there's two ways to do it. One is, and I think it's more complicated, but do inverse sine on this. You're going to get one angle, but then you got to figure out the reference angle for that angle and use it. The other way, which was what I suggested, was immediately treat this as though it's positive. So I would do sine -1 of 0.3425, sine -1, 0.3425. And I get S equals 0.3495, so it bumps and bumps again. This would be 0.350. But that's where it would be positive, and sine is negative here. So because it's negative, we're looking for the third quadrant and fourth quadrant angles. So I'm going to take my 3.14 and add the 0.350 to it, and I'm going to take the 6.28, and I'm going to subtract the 0.350 from it. And I'd get my two angles are 3.49 and 5.93. And then these are easy to check because I can sine both those. If I sine 3.49 and I sine 5.93, I should get my answer. Same thing with all the other ones. So these are easy to work in reverse to check. So this is not what's on your quiz. Your quiz, you're not going to have a calculator. So that's what you're about to see next. Any questions on these before we, because this, you'll see it probably on your test, like two parts like we talked about before. Yeah. It should be 3. Oh, it's so hard to see. 3.49 and then 5.93. You're welcome. Okay, so what happens if you don't have a calculator, but you do have your unit circle or you know how to use your unit circle? Okay, these are those kinds of questions. It literally will say find S over the interval of 0 to 2 pi and keep answers exact. So we are using the values on our unit circle for angles to figure out which of them has what's given. So I'm going to pull in a unit circle picture. I think this is the one that's, yeah, so that we can just easily reference it. So if you think about your quiz, you will have already filled this in, okay? And then those questions are going to be based on it. So instead of what we did last week where it would have said find tan of pi over 3, and I would know that answer is root 3 because you've memorized your over 3s by then, right? Instead of that, we're working the other way around. It's giving you the value of tangent, and you have to give the angles in which that exist. So if tangent is 1, what reference angle, or what's the denominator for the 1? Y over x being 1? All the over 4s, right? So it would be positive 1 in this quadrant. It would be negative 1 in this quadrant. It would be positive 1 in this quadrant, and it would be negative 1 in this quadrant. So you can either like write it all out or just know where you're looking. Yeah. So I know, remember we talked about like your over, so let's do over 6, over 4, over 3. This is root 3 over 2 and 1/2. This is root 2 over 2 and root 2 over 2. This is 1/2 and root 3 over 2. So this is your cosine, this is your sine, and then the tangent is root 3 over 3, 1, and root 3. So that would literally take care of all of the angles in between all the quadrants. And then you just got to know your quadrant angles, the 1, 0, all that stuff, right? So because the value is 1, I would look for where the tangent's 1, and that's going to happen on an over 4. It's positive 1, so we're talking first quadrant and third quadrant. So the answer to this question is pi over 4 and also 5 pi over 4. So it wants all the angles that would have a tangent of 1. Yeah.
How would you know if it was like in radians or degrees?
If it gives you S, it's usually in radians.
So it would be wrong if like you put.
I would say if it doesn't say it, assume radians for inverse ones. If it said, this is really the biggest hint. If it says 0 to 2 pi, that means radians. And if it said 0 to 360, it would be degrees. Yeah. Yeah. Which part? This one over here? Yeah.
Can you explain how you got that answer?
The one, or that you mean?
The first one.
So I know that tangent being 1 means it's got to be an over 4. So it's either going to be pi over 4, 3 pi over 4, 5 pi over 4, or 7 pi over 4, right? So then you want to look at the sign of it. Tangent is positive in quadrant 1 and quadrant 3. So I pick the over 4s from that quadrant. All right, go to 22. 22, God bless you, says cosine of S is negative 1/2. So I know my x coordinate is 1/2 at all the over 3s. And cosine is negative in quadrant 2 and quadrant 3. So I'm going to go to those quadrants, and I'm going to find where the x is the negative 1/2, the over 3s in that quadrant. So this is 2 pi over 3 and 4 pi over 3. (23) says the sine is negative 1/2. So the y is 1/2 at all the over 6s. And because it's a negative sign, I'm looking for the third quadrant and the fourth quadrant. So I've got a negative 1/2 here at the 7 pi over 6, and here at 11 pi over 6. And then 24, cosine being positive root 3 over 2. The x coordinate is positive root 3 over 2 at the over 6 in the first quadrant and the over 6 in the fourth quadrant. So this is going to be pi over 6 and 11 pi over 6. So we did these with triangles before your test, and I think this is when it's definitely a lot easier to use your unit circle. Like, you don't have to figure out your SOHCAHTOA. I don't have to figure out what my fraction would have been. I can just look at my x and y coordinates on my unit circle and know what the value should be. Yeah, so they're going to be like this, and then the reverse of this, like find cosine at 3 pi over 2, something like that. But more not directly from your unit circle, more coterminals, than which we're going to practice a little bit.
Are we ever going to have to like convert radians to degrees?
I don't think, I mean, we didn't make your test yet, but I don't foresee it being on your test like that. That would be the only time. It's not definitely not on your quiz. Yeah.
You said coterminals mean if something's not 4 or 6, or just like...
The bottoms are, right. So like that, and that's what we'll practice now because I think that's the hardest part. So if you want to add a slide, that's fine, okay? But what you will see, so like the quiz is half unit circle, and then the other half is a combination of either the original trig functions of angles, which is what we're going to look at right now, or the inverse ones, which is what we just did. So here's my value. You give me the angle. That's part of it. And then you're going to get stuff like the sine of 17 pi over 2. So do you remember what to do with these? Put it into a mixed number. So what is 17 over 2? 8 and 1/2 pi. And then the trick is what goes where? Evens on the right, odds on the left. So the 8 tells you to come here, start here. And then if it is a half, you actually stop at the top part here, which would be that pi over 2 angle. The coordinate point there is 0, 1. So the sign there is what? 1. So it could be sine of 17 pi over 3. 5 2/3 pi. So 5 says go to the left because that's odd. And then look at the smaller part. Is 2/3 less than a half or bigger than a half? Bigger than a half. So I go to the second quadrant after that odd number. And that's going to be in my fourth quadrant. And then I would locate the over 3 there, which is 5 pi over 3. And that coordinate point is 1/2 and negative root 3 over 2. So the sign there is negative root 3 over 2. If it had said, let's say cosine of negative 17 pi over 3, what changes, the odd doesn't change, right? This would still be 5 2/3 pi. The odd still goes on the left. It doesn't matter if it's a positive or negative odd. It would still go to the left. And then it's the direction you take after that. If it's positive, we would go in this direction like we normally do. Because it's negative, we're going to reverse the order. I'd go past the halfway mark. I'd grab the over 3 that's in that first quadrant. And the coordinate point there is 1/2 and root 3 over 2. And I know the cosine of that would be a positive 1/2. Yep, sure. Questions on these? So we'll do more review with this stuff tomorrow, but basically that's what it's going to be. It's either it's going to be half unit circle, and then it's going to be find the trig functions at these angles, and also find the angles given the trig function, all without a calculator. What? Wednesday. Same. So we added on stuff. So it's not just it's half. It will count for fourth quarter. Yeah.